Hello everyone. Apologies for the delay. YouTube and me aren't exactly on speaking terms, it seems, at the moment. Hello everyone. Good morning. I don't know why, as I said, YouTube and I are not. So, anyway, hello Sean, hello Riaz, hello Timothy, hello Kevin, hello Pankaj, hello Ken, hello Pat, hello Andrea Malala. Hope I'm saying it correctly. Hello Emma Cute, hello. Sean, he said there's something you've been trying to get. What can I try and help out? Let's see here. Let's make this larger. So, yeah, what kind of questions can I try and answer for you guys today? Just checking my stream settings and. So hopefully you've had a chance to view a few more of the videos. I've added a couple of things to the resources here. There's this MIT course about introduction to probability. I haven't actually viewed the videos or the material, but I'm assuming it's probably pretty good given their reputation. I put a link in about Apache Spark, but that's something I'm not going to be talking about in this machine learning course, but people were interested in, sort of resources beyond Unit 2. And the email Mondays and Wednesdays would be 1:30 UTC, while Tuesdays, Thursdays will be 8:30. That sounds mostly correct. I tried to fix my schedule yesterday online. This is showing up for me, in my local time zone. Hopefully, the schedule here should be showing up in your local time zone. Because today, right, the intention, although I was a bit late because YouTube is hating me. The intention here, this is 8:30 a.m. my local time. Which I believe should be, I thought that should be 12:30 UTC. like 8:30. I'm on Eastern Daylight Time to UTC. This is what I was trying the other day here. Because like I said, it's currently where I am, yeah, it's 8:41 a.m., which should translate to 8:42 a.m. should translate to 12:42 UTC. Whoever was sending out the emails, I don't know if we translated things correctly, taking into account the daylight savings time going on in the U.S., in most of the U.S. in general. So if I've translated things correctly, I believe it should be 12:30 UTC on Mondays and Wednesdays. And on Tuesdays and Thursdays, then, sorry, let me get this correct. Tuesdays and Thursdays should be 12:30 UTC. And I believe it should be Monday and Wednesday would be 20:30 UTC. That's what I believe the so what I said, if you look at the if you look at the schedule on the Jupiter Hub system, which I altered yesterday, apologies for my error, I believe these times right here for the live streaming office hours should be showing up in your local time zone. So these are showing up in my local time zones here. All right, I'll double check the emails and do my best to make sure that the emails for next week are sent out are showing the correct times. So, I mean, now that I'm here, now that we're started, are there, questions we could try and address about the course material? To me, it sounds like, Sean, are you definitely supposed to be in Unit 2? Those sound more like the office hours for Unit 1. That's the only reason I ask, because it does sound more like the So yeah, that's the reason I ask it. It sounds like the office hours you're telling me, Sean, are more like the office hours for Unit One. So so as I said yesterday, the this in mini project I believe should be identical to the one that you had in Unit 1 to remind you or introduce you to the grader. Yeah, so you don't want to alter these strings here because that's telling our grader, what kind of problem that they should be submitting the solution for. So don't alter this kind of string. Said these here you're providing this list. Here said you want to write a function that accepts the list and returns the list where each element is multiplied by 10. So we could do this kind of thing with a list comprehension. And we submit our function, and the grader runs our function on some test cases and make sure that your function is acting correctly. As I said, assuming you've done Unit 1, you're familiar with this grader and how to submit things. The same is going to be true when you start working on this ML mini project. So in this ML mini project, as it says here, we want to work on applying these machine learning tools that you learn about. Excuse me. And you might be doing some classification. I think the first question here, you're actually said we're looking at nursing homes, so inspection data, right? These are homes which are designed to take care of people, These nursing homes are inspected at various times, to make sure that they are satisfying all the regulations they have to, that they have to satisfy. And these nursing homes might be given fines, right? They're doing something they shouldn't be doing, or they're not doing something that they should be doing, and they will be fined for for violating some sort of rule. And we can download this data from S3. This is what this cell is doing here, is downloading this data that we're going to use. If I run this and cell, and then if I run it again, it will say, oh, this information already exists, so it's not going to retrieve it again. These are CSV files, so we could load this information into a pandas data frame using our knowledge about pandas. This right here is this kind of so-called metadata, right? It's going to tell us what the columns in our data actually correspond to. So this is the data that we have about these nursing homes. There's 29 columns in here. So we have things like this PROV NUM, as it says here, this is a federal provider number. This is some kind of, identifier, say, given to this nursing home by the federal government. This provider name, this is the name of this nursing home. We have information about the address and the city where it's located, the state. If I remove this .head, we get the list of all 29 columns. Ownership type, nature of the organization that operates a provider. This is kind of like, well, is this a kind of private place or some other kind of provider? There's a certification. Are they certified for providing or for getting payments under certain programs? So there's some information about, the sprinkler set, the safety equipment, about dealing with fires, some ratings about health inspections, and so forth. So this is the data that we have to work with here. Some of the information here is this information of how many fines was this facility assessed on and how much money were the fines in total. And as it says here, we'll have a very simple model here to predict the amount of fines a nursing home might expect to pay based on its location. And the point here is, this is talking about how we might go about building our own custom estimator in scikit-learn. right? So if you've not watched those videos, I mean, this will likely not make a whole lot of sense. Right, but in these videos, we talk about how you can build your own custom scikit-learn transformer, or your custom predictor, or your custom estimator, as I sometimes refer to them. And, this is what we're doing right here. Now, the idea is we have part of the information here, right? We have in this data about the nursing homes is the state in which they are located. And so what we want to do is we have information in this data frame about the state. It's this column here, the state. So states, these are the states in the US. How can I get this information? So my data frame is called the data. And I could get this series, and I could use this method called unique, and I could figure out what are the values in this column. And right, I see there's these various values for the states. And what we want to do is we want to build an estimator which will essentially compute an average amount of fines for each one of these states. And this is where we call upon, our pandas knowledge. All right, if I wanted to do this in pandas, I could take my data and I could say, well, I want to group by state. And the data that I'm interested in is these fine totals. Now, we've actually popped this data out of our data frame. So I think here, let me double check. Fine. Yeah, we've removed this data from our data frame here. We've stored this data in our fine counts. Right, but remember, if we group our data by a particular column, this specifies some groups, which are essentially sets of indices. And what we should be able to do see if this is, fine counts. Because we can actually group by, some some other information. Have to get this. Oh, I see. Because what we could do, is I could group my data. It's a bit sort of unconventional, because my find counts are stored in one series, and the data that I want to group by is stored in a different series. But Pandas is, helpful and smart and figures out what I want to do. Right, because the data state right here provides a state for every row, and I could take my find counts and group by this information in the state column, and I could compute a mean of this information here. Right, and this is the kind of thing that I want to do. I want to be able to do this, but I want to write a function which will do this more generally. Because I need to be able to write a function and take in, other data. And we're going to need to, be able to deal with, say, a state which is not in our training data. So what I said, I don't really just want to go about, giving you the solution, because, it's only the second day of office hours, and I'm guessing that maybe, half of you or more haven't watched these videos about how to build a custom estimator. And so, this code right here probably isn't making a whole lot of sense in general. But this is the idea of what I would like to be able to do is, as I said, the data state right here is providing information about this state column. I want to use this information about the state to group the data about the finds. And if I could group this information on the finds by state, well, then of course I could use my knowledge of pandas and compute this series. So this is a pandas series. I could, for example, also convert this to a dictionary just by calling this toDict method, right? A pandas series has a toDict method, which I can use, well, to translate a series into a dictionary. And of course then, well, if I have a dictionary, well, I could look up a particular value in this dictionary. And this is the kind of thing that I'm going to want to do when I build this custom estimator. At least I want to say look up something in the predict method. I want to basically create this dictionary in the fit method. In an estimator, generally we take our training data, we learn something from our training data in the fit method and store it in the estimator. And then we want to use this information that we've learned in the fit method to make predictions. And so we need to fill out we need to write the code, which will, as I say here, use these self.group averages to store the average penalty by group. So we create this dictionary right here. This is an empty dictionary. I basically want to fill in this dictionary in this fit method. And then in the predict method, I want to use the group averages to return predicted penalties based on in this case, whatever I grouped my information on. Which in this case is going to be the state, but we want to write a more general function to do that in this case. Now there's a couple of things that we're going to have to take care of, namely the information that we're going to get in the predict method is going to come in not as a pandas data frame. It's going to come in as a list of dictionaries. Where do we say this here? I thought we said this here in our description. The format of data that the grader will give you. I'm not seeing that in here though. So this predict method, the format that the data is going to come in is essentially going to be a list of dictionaries. So we're going to have to convert that to a data frame. In my predict method, inside of this predict method. In order to get this to work on data that we're going to receive from the grader. Now, the idea here, well, one is that we can't really send a data frame through our grader. It doesn't serialize well in our grader. And two, well, this is more like a realistic kind of use case where, say, we're going to be getting information maybe from an API, and the API is going to be giving us information in the form of, say, like a JSON file. Right? JSON would be like, a dictionary or a list of dictionaries. So one thing I'm going to need to add in this predict method is code like the following. I could check is my input to the predict method a pandas data frame. If it's not, I will convert it to a pandas data frame before I do anything. So here I'm going to check if the input is a pandas data frame. If not, converts to 1. Now this is the power that scikit-learn gives us. We not only have all of these built-in transformers and estimators and so forth, right? We could build our own. Estimator, let's say custom estimator. Right, when you could write your own estimator in scikit-learn using tools. You could even propose, an estimator for scikit-learn and see if it will be accepted into the library itself. Right, as it said, you have a you have a predictor, you have an estimator that has a fit method. If it's a predictor, well, it has a predict method. If it's a transformer, you have a transform method, and you have basically you also have a fit method. And we talk about here we talk about how you should define your init method. How you would define your fit method, how you would define a predict method. And they give some examples here. I mean, a lot of these things you probably don't need to read much about. This is really talking about if you want to develop an estimator and propose to include it in scikit-learn. So, as I said, this is probably more information than is needed. It's it's really this kind of template to follow. Here, this is for like building a classifier. Excuse me. And again, in the videos we talk about, we give examples about how you can build your own custom transformer and custom estimator. And in this mini project, we're starting out with something simple to build your own estimator. Do you guys have any questions that you want to ask me right here? At the moment, I feel like I'm talking into the void and don't know if anyone is listening. So, as I was saying yesterday, these office hours are really designed for you guys. So, these will work better if you bring questions to the office hours. Questions about the material. I said I do realize, of course, that you may not have watched all of these videos. And I wouldn't expect you on day 2 of the program to have begun working on, say, this ML Mini project. This is why I'm just kind of discussing this project, and I don't want to sit here and just type code. I could obviously give you the answer here, but I don't want to just sit here and type code if you've not watched the videos and would be able to understand, and we could talk about, what I'm doing here. Still no feedback here, no messages, no comments. So it says I have 35 viewers and but no comments here. Um, Alright, in that case, maybe I will continue searching for my mathematics and probability links, as no one has any questions for me here. I'll double check. So, let's see here. What's this here? Alright, let's add this example about Bayes' theorem here. Bayes' theorem is quite an important concept in probability theory. Bayes' theorem, problems, definitions, and examples. What is Bayes' theorem? More examples. Medical tests, yeah. Yep. Another way, yep. Other forms, yep, sure. Seems like just want good examples here. Example, Yep, alright. Intuitive and short explanation of Bayes' theorem. Looks somewhat similar, but yeah. More things are better than fewer things. Bayes' theorem is it's used a lot, even if we use it kind of intuitively. It'll go away. Bayes' rule. Simple and practical example. Bayesian inference, drug screening, yep. Yeah, this looks pretty good. So there's five links for Bayes' theorem. And someone yesterday was asking me about interview questions. Interview questions that you might, questions you might see on a interview, or you might encounter on an interview. So here's a couple of questions. Oh, this is too long here. All right. So here's a probability puzzle. As I said, I can't recall who was asking about it, we could say, but someone yesterday was saying, what are some questions you might encounter in a technical interview? Well, here's a kind of basic probability question for you, which I've typed into the chat. So you have 3 baskets. Each basket contains exactly 4 balls. Each ball is the same size, weight and so forth, and right. The only thing that's different about them is their color. So each ball is either red, black, yellow, or orange. There's one of each color in each basket. If you randomly draw 1 ball from each basket, what is the chance that you will have exactly 2 red balls? This is obviously very different from machine learning, but this is the kind of question that you might encounter in a technical interview. As I said yesterday, having some knowledge of probability is only going to be helpful. And I'm out of time for today's office hour, so you guys can think about this puzzle. As I said, these office hours, I'm expecting really you guys to come with your solutions. To come with your questions. So I will sign off for office hours today, and I will see you guys back here tomorrow, and maybe some of you will bring a solution to this puzzle. So I will see you guys tomorrow.